Welcome, future developers. It's here. Last lesson of our introduction course to Python. Today we are going to put a cherry on top. It will be about object-oriented programming. This is a concept which allows developers to organize their code in a way better and more understandable way. Even when you are thinking about your program, it gives you an option to create something like blueprints and specific objects based on them. And it mirrors how we perceive things in real life. If you think about table, there are various types of tables. They look different, but we can still say if it's a table or not. There are some common features, or something more abstract such as animal. You know what animal is, and there are some things which makes animals the animals. So it might be useful if you are thinking about a game or whatever ready, to have dog and cat with some common denominator. Because they have some things in common, and if possible, we don't want to write the common things over and over again. It's enough just to write them once and reuse them later. And this is what classes, objects, and object-oriented programming really is about. So to start with object-oriented programming, we are going to start with classes and objects. Class is blueprint, and object is something derived based on the blueprint. Let's say we have a game where player can choose his or her character. So in that case, we can create class player. We can specify some basic characteristic: name, health, and strength. I created two new players, hero and sidekick. They have both the same blueprint, but their actual existence is derived based on the data I added later. Think about it. Player by itself is nothing, right? It doesn't exist. We should make it real by adding some real values, some real attributes to it. It is the same with the animal. Animal might be taken as a concept, but if you want to be specific, you can use dog, 4 legs, it can bark, it's your best friend. In this class, you can already see two things which might seem a little bit suspicious. First is self. Self is a Python way how to reference the object itself. It must be there. And the second thing you might ask is why the init method looks like that. We are going to talk about it in a moment. If we talk about class, we are talking about attributes and methods. Attributes are variables. Methods are functions. And nowadays, when object-oriented programming is everywhere, it's pretty common to mix functions and methods together. If someone's talking to you and using words such as function, he might mean method, it means function, let's say, dedicated to some particular class, or not. But it's not even that important. So here's a proposal of a class of some NPC enemy characters. There are attributes and there are methods we might be interested in. And you can create as many various enemies as you want based on this blueprint. Talking about methods, let me tell you about these double underscore ones. These are called magic methods or dunder methods. And they're special because Python will call them in some specific situations. If Python expects something specific to happen in this particular time, and you have the magic method for that particular time, it's going to happen automatically. Such as init. Init is something what in C++ world we can call constructor. Every time when you create the object, the first method which is going to be called from the class is the init method. And there are way more. Talking about object-oriented programming, we must mention the 3 key concepts. That's encapsulation, inheritance, and polymorphism. Encapsulation means that all attributes in your class shouldn't be publicly available. There might be exceptions though, but in general, the class or the object itself is responsible for its own data. Let's imagine that you are working on alarm clock. You can have variables for minutes, seconds, and hours. If you allow user or developer to set these variables directly, you might have a problem. What's going to happen if developer or user will fill up 26 hours, 1,000,005 minutes, minus 5 seconds. If you have a methods working with these particular numbers, for instance, you want to set an alarm, well, your application will not work, right? It might even crash. So you have the attributes, time in this case. If you want to set the time or read the time, you are creating setters and getters methods, something like set time or get time if you need to read it. Advantage is that if you have a specific method dedicated to set the time, you can add some ifs, you can add some check if the values are reasonable. So I will keep the data inside untouched, whatever it was there before. I will not change it, and I will inform the user that he or she input invalid value. I'm encapsulating my class, my data from the outside world, and I'm only providing the interface to change them. Whereas here I have inventory system and I have the list of items. I have specific method to add new items, and I have specific method to use the items. And you might see I'm checking if the item actually even exists. Second is inheritance, and this is a thing which allows you to add certain specializations. Let's say that you have some general idea, you have some blueprint, but you are really not ready to make object out of that, because you can make another blueprint which is even closer to what you want, but it's still very general. Such as here I have a character, right? I have some generic character which would contain generic character things, but I might create another class called warrior, which is like the specialization of the character for being a warrior. It means I can add some warrior specific things. I can create object warrior from class character, where the warrior can be some identifier, but it might be better to have a specific class just for warrior, because I can have plenty of warriors. All of them are warriors, but their numbers are different. Inheritance in Python is very straightforward. You are just going to specify from which class you are going to derive your class. What happened is that everything from the class above is going to be available in your subclass. If you need to call something from the class above, you can use super function. And the third one is polymorphism. This allows you to treat every class and subclass in the same way, but with different behavior in the background. Let's say that I have class weapon, very generic thing, with only one method use. You can think of many weapons, and their usage is actually quite different from each other. Weapon is typical blueprint, typical class, very abstract. I can derive another class, sword. The class will inherit from the weapon, so it will contain the method use. If you are talking about sword, it's still very general, right? It's still blueprint. You can have many types of swords. But the usage of the sword is actually well defined. You can swing, you can stab. So whereas general weapon have a way how to be used, we don't know what the way is. But with the sword, we already know. Same for bow, same for staff. And here is a cool part. I can create sword, bow, and staff as the object of appropriate class. I can call use for all of them, and I know that every object contains method use, because their parent does. Create your own weapon derived from the weapon class, and don't specify the use method. You will see what's going to happen. Time for our last project. We are going to take our text-based adventure and spice it up using object-oriented programming principles. Enter your hero's name. Pavel. Welcome, Pavel. Your adventure begins. Goblin appears. Pavel's health, Goblin's health. Your action, attack or run. I want to attack. You deal 10 damage to Goblin. Goblin deals 3 damage to you. So our health decreased. Goblin's health as well. Attack. Attack. You deal 10 damage to Goblin. You defeated Goblin. Do you want to continue adventuring? I want to. Goblin appears. Let me kill him again. And that was enough. Game over. Monster defeated 2, final level 1, final health 88. Let's begin. We are going to import the random library, or random module to be precise. You can see here some class declarations with functions declarations below. We'll already know what to do. If we want to find where the program actually starts, we should scroll down. And we can see that the first function, which is not actually definition or class method, is here, main. And main is defined here. Welcome to the text adventure. That's here. Enter your hero's name. Peter. Welcome, player name, your adventure begins. Great. Here is a counter to capture how many monsters has been defeated. But before we take a look here, let's investigate a player. I created new object based on the class player using a player name. So let me take a look how the class looks. As you can see, the class inherits from class character, which is right above. In a constructor, I can see that I have name, health, and strength variables. I have a method isAlive, checking if the health is higher than 0. I have a take damage with a damage as a parameter. Not surprisingly, this is the amount which is going to be subtracted from the character's health. And here is just a nice thing to do. If we should end up with the negative health, it's better to cap it on 0. And the character has an option to attack using its strength. And now for the player. I use method init from the parent using these parameters. I say that the player has certain levels starting at 1 and some amount of experience starting at 0. My player can gain experience, where every 50 calls leveling up, and the leveling up defined below leads to level increased by 1, increased health, strength, and a reset of the experience counter. And also I inform player that something like that happened. Let me scroll down and check out the game loop. While player is alive. I'm going to repeat this loop as long as player is alive. For the monster, I use function createMonster using player level as a parameter. Function is here. Monster type, and here I'm taking minimum from the player level divided by 2 and the number of monster types minus 1. Len is abbreviation for length, and it simply means 4. Minus 1 is 3. The minimum here is for the situation where the player level would be so high that the new monster wouldn't exist. So I'm assuring that the maximum number we are going to choose is 3, which is the monster with the ID 3, and because we are starting from 0, it will be troll. And what I'm returning from this method is actual object of the class monster with these parameters. So here is the list of the monsters and their respective values. Here, the specific monster is selected and its values are sent to a constructor of the monster class. Let's take a look on the monster. Control-click. I'm using the input parameters and choosing some of them to call the constructor of a parent. Parent here being character with name, health, and strength. However, the new parameter, which is by the way not available for the player, is telling me how much experience the player is going to get for defeating the monster. And I'm going to remember that. We are going back and coming to a phase of a battle. I have player and I just created a monster. So now it's time to put them together. Method battle is right here. Monster came in a parameter, and for the introduction message I'm using its name value. And that's here. Goblin appears. While player is alive and monster is alive, this is going to happen. So here is another loop which is going to be repeated as long as player is alive and monster as well. Player names, player name, health, player health, monster name, health, monster name. As you can see here, I'm asking for an action, attack or run. If player choose attack, I'm going to remember what damage the player dealt. And as you remember, the attack method is defined as strength of the player or of the monster. For my monster, I'm going to invoke method takeDamage using the damage dealt by player as a parameter. And here is a message informing what happened. So, attack, you dealt 10 damage to Goblin. We are moving. If monster is alive, which it is, we are going to do the same thing, but now, not that the player is attacking, but the monster is attacking. And I'm going to save the value to damage the player. I'm going to invoke takeDamage to damage the player and write the same message as before, but now from the monster's perspective. Goblin deals 3 damage to you. I can skip all the other branches and come back here. Player name, monster name. As a refreshment, the takeDamage method just take the damage and subtract the value from the health. Now I can try to run. You successfully escaped. Nice. Here I have certain probability. I'm going to roll a dice for some random number between 0 and 1 and asking if the number is higher than 0.5. If yes, we are successful. Return false cause jumping out from the battle function. Because we run away, the method return false, this is not true, and monster defeated is not going to be incremented. I'm asking if the player is alive. If it's not alive, we are going to break from the game loop and jump out, but well, we are alive. So we are asking, do you want to continue adventuring, yes or no? If we write yes, that's alright, and if we write anything else, we are going to break from the loop. I'm using yes, and now I'm going to repeat several attacks until I reach level 2. You defeated Goblin. Petrol leveled up. New level 2, new health, and new strength. Which is happening here in the level up method. Do you want to continue adventuring? Obviously. And now skeleton appears. Did you notice? Because we leveled up, instead of a goblin, we met skeleton. And the situation repeats all over again. This was pretty straightforward, just an inspiration how you can utilize the classes, objects, and object-oriented thinking in your own projects. Now it is a great time to connect everything what you learned together. You can add inventory to this version of the game. You can add save and load system. And you can make the combat system way more difficult with your own math and your own formulas. So, get crazy. Here we are. End of our Python journey for now. First, I want to say thank you. Whether you are watching from the first lesson or just jump in along the way, it's great. It's amazing. I really appreciate it. We started from the beginning with the basic, like getting our Python environment set up, writing the very first line of code, and learning why Python is such a powerful tool, especially for prototyping, even in game development. From there, we dove into variables, data types, operators, loops, conditionals, all the way to the heavy hitters like file handling, functions, and even object-oriented programming. Remember the simple text-based game we started with? By now, you've got the tools to transform it to something much bigger. Whether it's full RPG, simulation, or whatever idea you are dreaming up. It's been amazing to show how Python can go from something as simple as a print statement to creating inventory system, saving game progress, and defining entire character classes. Now a quick reality check. This is not how it ends. This series gives you a solid foundation, but there are way more things to talk about. Don't forget that the great thing how to learn new things, and really the only one way when it comes to programming, is to actually sit down and write a code. Don't be afraid of breaking the things and try to fix them. Experiment, keep pushing yourself, and if you are stuck, just don't hesitate to ask. It is all about the trial and error. Every bug you fix is a win. Every mistake you made has a learning opportunity, because by overcoming the mistake, by understanding what you did wrong, you learn a new thing. And please keep the projects you are working on right now. If you become a professional developer, if you will have a career later, it will be a nice memory for you to go back in time and saw what you did as your first project. Thank you again for being part of this series, and if you like what you saw, subscribe. Now go write some amazing code, and most importantly, have fun doing it. See you next time.